Assalamualaikum and hi captains. So today we are here on the flight mission, the captain task. So in the video today, we are going to look at how to sketch free body diagram and to apply summation F is equals to MA along the chosen axis. For question 1, we have a smooth incline at 30-degree plane. So this is my smooth plane, incline at 30 degree, and this is smooth. Smooth here indicates that there is no friction, and a 40 kg block A sits on the plane, so the block A is 40 kg, connected to a string over a frictionless pulley. Frictionless pulley here refer to this pulley which is frictionless, indicating the tension is the same on both the side of the string. The string here and the string here, since they are the same string and the pulley is frictionless, they are going to experience the same tension. And this object A is attached to object B, which is 28 kg. 28 kg, which is hanging freely, and the question has asked us to draw the free body diagram for both the blocks and also to calculate the tension and acceleration of the block. Alright, so before we sketch the free body diagram, it's good to identify the forces that is present in the question or the body first. So now we have two blocks, blocks A and block B. So for block A, the block A is on an surface, inclined surface, connected to a string. Therefore, this body here is going to experience normal due to the touching of the surface and also the body. So we're going to have normal force. Normal should always be perpendicular to the surface, and then I'm going to have the tension because the body is attached to the string is touching the body. We're going to have tension. Tension should always be away from the body along the string, and then I'm going to label this as TA. And also, every body has mass in the earth must experience weight. We're going to have weight force. Weight should always be pointed straight down to the center of earth. So this is my W, labeling it as WA, just to distinguish between the two body here. All right. Is there any other forces? That's it. There is no other forces. There is no friction between the surface and also the body because our plane is a smooth plane, no friction. Next, I'm going to look at the second body here, object B. The object B is connected to the string as well. So I have string, and then if I have string, I'm going to have a tension here. So this one I'm going to label it as TB. And then the body has mass, is in the earth. We're going to experience weight here, WB here. Any other forces? No other forces. The body is not touching any surface. Therefore, these are the only forces exist here. Okay, and then I'm going to emphasize again on the TA and TB here. As I've labeled them TA and TB, this is just to distinguish that the tension experienced on this part due to body A, and the tension is experienced on this part of the string due to body B. Okay, however, since they are the same string connected across a frictionless pulley, the tension is going to be the same. So TA is equals to TB. Let us simply label them as T only. So I'm going to erase this one. Okay, so now we are going to answer the first question, which is to sketch the free body diagram. So to sketch the free body diagram, as I've introduced at the beginning of the video, that we are going to establish the coordinate system. We're going to have x-axis, y-axis. So for that, let us start with, we have two objects, object A first. So for body A, we have the object on an inclined plane, tilted. The surface here is tilted, therefore it is advised to use a tilted Cartesian plane as well, which means you're going to have your x-axis and y-axis, which has been tilted than the usually view. Usually we have x and y, something like this. So now we are going to simply tilt them to have it along the surface as well. Your surface and your x-axis are parallel to each other. So now I'm going to establish my Cartesian plane, x-axis and y-axis here using a dotted line. Okay, so do not use solid line here because the solid line is going to represent the forces that the body is experiencing. Next, I'm going to use a dot at the origin to indicate the object, and then I'm going to simply transfer all the forces that I have already identified without changing the direction and making sure the vector should not pointing towards the origin. So my first force here is the normal force, normal, perpendicular to my surface, which is the x-axis, and then I have tension along the x-axis, and then I have my weight straight down here. This is my W. Okay, so since my body is on an inclined plane at an angle of 30 degree, I'm going to insert this 30 degree into my diagram here. I'm going to transfer my 30 degree into the diagram here. So for the 30 degree, where is it going to be located? The 30 degree here is going to touch the W and also the Y axis. This is my 30 degree. between the W and also the Y axis. Okay, so as you can see here, this is my X, this is my Y. So the theta at this end usually touches this end because you have a right angle triangle here. Consists of the plane, the surface here, and the W here. This is a right angle triangle. If this is 30, this is always 90. You get this as 60 degree. Therefore, this part here is going to become 30. Okay, next we're going to continue with the free body diagram for the object B. So for object B and B, I'm going to have the forces. So for this part, I will not have any issue with the x-axis and y-axis. I'm going to draw the normal x and y without tilting them. Okay, so I'm going to place my object at the origin. This is my block B. And then I'm going to transfer all the forces I have identified, the tension here, and the weight straight down. Okay, these are the forces here. Alright, so since we are done with the sketching of free body diagram, we can now continue. But before calculating, we must know which way the system moves. Okay, so you must be thinking that because block A is 40 kg, which is heavier than block B, 28 kg, A will automatically slide down. However, we don't compare the masses. Okay, remember, do not compare the masses. We compare the specific forces acting along the line of motion. Okay, so what you have to compare is the forces acting along the line of motion. So since the object A is along the inclined plane, we know that the object A can only move up the inclined plane or down the inclined plane. Whereas object B is going to go up or down. It's either way. Could go up or down. So if object B goes down, the object A is going to go up the inclined plane. And if object A is going to go down the inclined plane, and object B will go up. So for that, as we can see, the direction of motion for object B is along the y-axis. And the forces that is going to act along the line of motion is the weight, WB. Whereas for object A, the direction of motion is along the x-axis, which is parallel to our surface here. The force that is going to act along the line of motion is part of the weight, only a component of its weight, which is, as we can see, W is here. I'm going to use this free body diagram to explain. My W is here. I'm going to have my WX and WY being resolved here. So this is my WY and this is my WX. Therefore, this WX is the force acting along the line of motion. So here we are going to compare WX and also W in order to see which one is much heavier and which object is going to pull the other object. So to start comparing, I'm going to calculate my WX. WX is going to become W sine theta, which is W is equals to mg sine 30. I'm using this angle here. The angle is touching my y-axis. Therefore, my x-axis will take sine here. And then I will have mg sine 30 as 196.2 Newton. My mass is 40. My gravity here is 9.81 only. Therefore, I will end up with 196.2 Newton. Whereas for my WB here, when I calculate my WB, I'm going to get M multiplied with G, where the mass of object B is 28 kg. 28 multiplied with 9.81, I will end up with 274.68 Newton, which shows us that 274 is much bigger than 196. Therefore, WB is greater than WA in the x-axis. Thus, the object is going to be pulled down by WB. Indicates that the direction of acceleration for object B is downward and for object A is upward along the inclined plane. Alright, so now we are going to look at the question B, which is to calculate the tension and also the acceleration. So for that, what are we going to do is we are going to apply the equation, which is Newton's second law. According to Newton, summation F, the total force acting on a body must equals to the mass of the body multiplied with the acceleration of the body moving. So since we have forces involving the x component and y component, as you can see, I have my normal in the y component, my tension in the x component, and my W, which is in between x and also y. So I have forces in both these axes. Therefore, the summation F here must belongs to both the components. I'm going to have summation Fx in the x component and summation Fy in the y component. However, as we have already deduced the direction of motion, the acceleration is moving along the x component. The summation fx will equals to ma and summation fy will equals to 0. And as the question has asked to calculate the tension and also acceleration, where both my tension and acceleration are in the x component, x-axis, I'm going to start to solve by opening this summation fx. So summation fx here is equals to ma. For my object A, I have two forces involved in the x-axis. The two forces are the tension and also the wx, which I have resolved. So summation fx means we are going to sum all the forces that are involved in the x-axis. So I'm going to sum the forces here. So since my acceleration is to the right, everything on the right is going to become the positive. We are going to follow the direction of acceleration. If acceleration is going to go up along the inclined plane, everything on this side here is going to become positive. So my tension is to the right, whereas my wx is to the left. Tension is positive and wx is negative. So tension plus negative wx, I will end up with T minus W is equals to ma. This is for object A. So my tension here is an unknown minus wx here is what we have calculated earlier basically, which is mg sine theta is equals to ma. This is also ma. So my tension minus m is 49.81 sine 30. Sine 30 is equals to 40a. I will end up with T is equals to 40a plus 196.2. And this is my first equation. I'm going to be stuck here. I cannot proceed because I have two unknown. When you have two unknown, you usually need two equation. So we have got our first equation using the first object, which is object A, which has the tension and acceleration in the x-axis, and I have opened my summation fx to end up with my equation 1. So next, I'm going to look at my second equation, which is going to come from the second object. Okay, why are we looking at the second object? It's because the same T and A, which has been asked in the question, and also the unknown that is present in this equation 1 exists in the second object as well. Therefore, now we are going to apply Newton's second law for the second object. So for the second object, summation F must equals to ma also, because this is Newton's second law. And our object has an acceleration in the y-axis. Therefore, my summation Fy now will equals to ma for object B, because the acceleration of the object is moving in the y-axis direction. Okay, since there is no any forces in the x-axis, I'm not going to open any equation for the x-axis. Summation Fy means that you're going to sum all the forces in the y component. I have two forces here, tension and also the W. But before that, since my acceleration is going to go down, therefore anything going down is going to become positive, as we are making our acceleration positive. Direction of acceleration is a positive. Therefore, all the forces in the same direction as the acceleration is going to become positive, and the others are opposite to it. So my tension is up, my weight is down, acceleration is down. Therefore, to sum my Fy, my W is a positive value, positive WB, plus negative tension because in the opposite direction. So minus tension is equals to MBA. What is WB? WB is mg. M of object B multiplied with G minus T is equals to MBA. M is 28 times 9.81 minus tension is equals to 28A. Therefore, I will end up with T is equals to 274.68 minus 28A. So this is my second acceleration, second equation. So previously I had an equation with T is equals to 40A plus 196.2, and my second equation also T is equals to 274.68 minus 28. Therefore, I'm going to equate my first equation with the second. I will end up with 40A plus 196.2 is equals to the second equation, which is 274.68 minus 28A. And then you can do your max here. Bring to the right, bring to the left, rearrange, and what's or not, you will end up with your acceleration such as 1.15 ms negative 2. So this is your acceleration. The value of acceleration is positive 1.15 ms negative 2. Now, the question also asks to find the tension. So since you have already obtained the acceleration, you can substitute the value of acceleration you have obtained in either equation 2 or the equation 1 in order to get your tension. So let's say I'm going to substitute them in the first equation. So my tension was 40A plus 196.2. So 40A is 1.15 plus 196.2. You press your calculator and you will get 242.36 Newton. This is the tension that is experienced by the string here. Okay, so for question 1, you will first ask to sketch free body diagram. This is the free body diagram where you have for object 1 normal, tension and the weight. For object B, you have the tension and the weight here. And then for your calculation, before you do any calculation, you have to first identify the direction of acceleration. So for this particular case, the direction of acceleration is obtained by looking at the forces that is acting along the line of motion. Okay, so the acceleration for object A was along the x-axis and we have Wx here. We're going to compare with the acceleration for object B, which is along the y-axis, which is the Wb. So when you compare them, you get Wx as 196 and Wb as 274, which is 274 is greater than 196. Therefore, acceleration is going to go down for the hanging object and go up along the inclined plane. Then you can do your question B, which asks you to determine the summation, which asks you to determine the tension and also the acceleration. So let us continue with the question B. We have block A 12 kg and block B 18 kg sit in a contact on a smooth surface. So these two bodies are in contact on a smooth surface, and we know when we have smooth surface, there is no friction exists. A 200 Newton force is applied to block B at an angle 30 degrees above the horizontal, and the system accelerates at 5.77 meter per second, which indicates when we push the object here, this entire system, as in you push object B, object A is also going to move, so they are in one system, and this system is going to move with an acceleration of 5.77 meter per second in this direction. So the question has asked us to sketch the free body diagram for block B, so only for this particular object, and calculate the normal force acting on block B, and also to determine force exerted by block B on block A. So before we sketch the free body diagram acting on object B, we are going to identify the forces acting on object B, the block B. So since the question only asks for B, I'm going to focus only on B. We have a normal force here as the object is placed on the surface. This is my surface and this is my body. So I'm going to experience a normal force. So the normal force should be perpendicular to the surface. And then we are going to have weight as the body has mass and is placed in the earth. Obviously, we're going to have weight. So this is the weight. Okay, next we have the external force acting on the body in this direction. It is mentioned here already clearly. And then we have another contact force between the object A and also object B. Since the two body is touching each other and the object B is going to push, and the object B is being pushed by external force, thus the B is going to push the object A and object A is going to react. So we have another contact force, we call it as action-reaction force here, which is exerted from body A to body B, from block A to block B. Okay, so this is my force between A and B. By A on B. And then do we have any frictional force here? No, since the floor is a smooth floor and no friction here. So now we are going to answer the first question, which the question has asked us to sketch free body diagram for block B. So I'm going to establish my Cartesian plane, coordinate system X and Y. This is my X and Y. And then next, I'm going to transfer all the forces acting on the body. So we have identified normal force. So this is my normal, straight up. Normal, my weight, straight down, W. And then I have the external force acting in this direction. But since the force here is entering my object, and when I transfer it in the Cartesian plane, we can never have any vector pointing towards the origin. So without changing the direction, I'm going to only change the position so that it does not enter the origin. I'm going to place my vector here. So my force here will be sitting in the third quadrant. This is my external force with the same direction, no direction change, with the same angle here. So the angle is going to be 30 degrees here. And then I have my contact force between the body A and body B pointing to the right. So this is my FAB. So these are the forces that we have identified, and then as we have been given in the question, the object is being pulled by the external force. Therefore, my object is going to move in this direction. This is the direction of motion. Okay, since we have already identified the force and sketched the free body diagram, we're going to proceed to the second question. The second question has asked us to calculate the normal force. Okay, so to calculate the normal force, we are going to apply our Newton's second law. So any calculation in this chapter involve the equation of Newton. Summation F is equals to ma. Since the acceleration, where my object here is moving along the x-axis, my summation fx will equals to ma. And summation fy automatically becomes 0 because there is no motion in the y-axis. The object is only moving to the left in the x-axis direction. And the question has asked us to calculate the normal. Normal is along the y-axis. Therefore, I'm going to look into the summation fy. I'm going to open my summation fy to get the normal. But before that, the normal here is in the y-axis. The FAB is in the x-axis. W is in the y-axis. However, my external force exerted is in between the x and also the y. So I'm going to resolve them first to make it easier to sum the forces along the axis. Before we sum them, we must place all the forces in the x-axis and y-axis. Now, all the forces are already being placed in the x and y. I can do my summation fy. So my summation fy should equals to 0. I'm going to sum the forces in y component. So in y component here, I have normal, fy, and also wb here. I'm going to simply sum them. I have my normal pointing up, positive n. My fy and wb pointing downward, negative fy and negative wb. So to sum them, I have to add n with fy and wb. So n plus the negative of fy becomes minus fy, plus negative of wb becomes minus wb equals to 0. So the normal here is what we are looking for, fy. Since my theta here touches the x-axis, my y-axis will take sine. F sine theta minus w is mg equals to 0. So n minus the normal, the external force is given as 200 sine 30 minus the mass of object B is 18 times 9.81 as my G is equals to 0. So the normal here is equals to 276.58 Newton. So this is the value of the normal force acting on object B due to the surface. Now let us look at the third question here. The question asks to determine the force exerted by block B on block A. So the question is asking force on the block A. So what we had earlier was the free body diagram that we have drawn for block B, and we were solving the normal force for block B. So the object that we were objectifying is the block B. But now block A is our object here. So for that, you have to first understand what force is the one they are asking here. So as we can see, the block A and block B are touching each other. That the contact surface here has two forces on them. Okay, where the block B is pushing A forward as it has been pushed by the external force and create a force B on A. At the same time, the block A is pushing B backward. This is the force A on B. So according to our free body diagram for object B, we have identified this force. So this was the force by block A acting on block B. Okay, now the question is asking this force here, the first force, which is on A. So according to the free body diagram for object A here, I'm going to have a normal force for object A. This is the normal force here. And I'm going to have the weight here for block A. And I have this force by B on A, the force that is acting on A, pointing to the left. This is my force. And the question has asked this force. Okay, so basically this force, this BA and AB are action-reaction force. They have the same magnitude but opposite direction, acting on two different bodies. So they carry the same number. As I find either one, I have answered for the another one. Basically, if you find the force BA, they should have the same value for AB. That is what Newton's third law states, that every action, there is a reaction with the same magnitude but opposite direction. So basically, to find the force acting on AB, it is the same as finding the force acting on BA. They are the same. So we have two approach on how to solve this question. Okay, I'm going to show both the way. So for this part here, we are going to use the object A as, block A as our object here lah, to objectify them. So block A is being pushed by block B, thus the object is going to move in this direction. Okay, so I'm now going to apply the Newton's second law to find the force acting on block A due to block B. So summation F is equals to MA, and the acceleration is along the x-axis. Thus, I will have summation Fx is equals to MA. So my summation Fx for the block A, I only have one force along the x-axis, and my acceleration is pointing in this direction left. So the force here is in the same direction as the acceleration. Since they are in the same direction, so it is a positive FBA. That is the only force along x-axis equals to MA. And what is my M? The body A has a mass of 12 kg. The acceleration is given 5.77. I will get my answer such as 69.3 Newton. That's it. That's the answer for the force exerted by block B on block A. However, we have another approach to solve this question. This is one option. We have another option. So for another option, we are going to use the body B as our object. Okay, because they have the same magnitude. So let's say I did not use this approach because I have already answered my question 1 and 2 using free body diagram from object B. Can I still solve this question? Yes, since we know these are the action-reaction force. When the question asks to find FB on A, they are the same as FA on B. So for that, I can simply find the FAB using my body B. So we have already deduced earlier that summation Fx is equals to MA for body B. And I have two forces acting on my x-axis. I'm going to sum them and equate to MA. Since my acceleration is pointing in this direction, my Fx is in the same direction, so Fx becomes positive. So Fx is positive plus Fb is pointing in the opposite direction, so minus FAB is equals to MA. So we are looking for FAB, so Fx is F cos theta minus FAB is equals to MA. F is 200 cos theta is 30 minus FAB. This is what we are looking for, is equals to 18 multiplied with 5.77. And then if you press your calculator, you will end up with 69.3 Newton, the same answer. Because they are action-reaction force, they have the same magnitude. What I'm trying to convey here is that you have two options on how to solve the question. Okay, since you have already got the free body diagram for object B, even though they ask the force exerted on A here, since this is an action-reaction force, can be solved by finding this force? Yes, because they are the same. You can simply state this to indicate that the question has asked the force by B on A, but you know that the force by A on B is the same, so you find by A on B, and you get the answer.